All right, so we're going to talk about your warm-up problem. One thing that you might want to do is just add some parentheses to keep your denominator together. Whoa. All right. And then the minus in here, it's not absolutely necessary, but it could be helpful to change the minus to what, Gideon? What'd you change the minus to? A plus negative, right? Yeah, I saw that. Ugh, I don't like that seasick thing. Okay, so now we have to multiply each fraction by what it's missing in its denominator. So the denominator is going to need to have x plus 2 and x minus 1 in it. You all right, Alec? You okay? You were like asleep with your eyes open. All right. So we have x plus 2, and then I'm going to multiply it times x minus 1 over x minus 1. Plus negative 4 over x minus 1, and that one's missing the x plus 2. Okay, that one has x plus 2, and it's missing the x minus 1. All right, what questions do you have so far? All right, make sure you're paying attention. You're going to need this for today. I'm not going anywhere. I am going to put these two fractions together with a common denominator. We can discuss that in a minute. I don't remember. But generally, if a person arrives late, that's how I mark you. All right, so I'm going to distribute the 3, and I'm going to distribute the 4, and I'm going to distribute the 5. Oops, so it's not a 4 though, is it? You guys see that? I forgot the negative. So make sure you don't do like that. Don't forget your negative. Okay. All right. How can I get rid of those denominators? Multiply. Very good. I'm going to take a question. Go ahead. 3x minus 3. Yes, guys. Sally caught my error here. Did you guys see that? This is supposed to be 3x minus 3. Make sure you made that fix. All right. And then you guys said to get rid of our denominators, we can multiply. Yes? So,
or are you just doing that to like fix a problem on like
oh, it was a step, yeah. So minus is the same as plus negative, right? So I changed my minus to plus negative to make sure that I kept the negative with the 4. Some people are able to do that without changing it to plus negative, and you know they can keep track of things that way. For me, I just need a little bit more organization. All right. So to get rid of my denominators on both sides, I just multiply by that denominator, x minus 1, x plus 2. I can do that because I'm doing it to both sides of the equation, and it's still going to be the same. It's still going to be balanced. So the x minus 1's cancel, the x plus 2's cancel, like that. I can combine like terms on the left. So 3x minus 4x and negative 3 minus 8. Am I doing all right, Sally? I'm counting on you. Bless you. Okay. Next, I like to get my x's to one side, so I have two choices. I could add 1x to both sides or subtract 5x from both sides, and they both work. What do you guys want to do? Subtract?
Yeah.
If you want to add, go ahead and do it, because we should get the same answer. All right, to get x by itself, I'm going to add 11. And now since I have negative 6 times x, I'm going to divide by negative 6 on both sides. What do I need to check? I need to check the negative 1 to see if it makes the denominator equal what? 0. Yeah, you can't have a denominator of 0. So when I check it, I just substitute it for the x in the denominator. Negative 1 plus 2. That does not equal 0, so I'm good.
Oh, and Miss Bill,
Yes.
if there's like
Oh, I forgot the other one. What's that?
if there's no solution in delta math, how are we like supposed to do it?
It's a good question. Guys, I forgot to check the negative 1 minus 1, but that's also not 0. So what do you mean there's no solution in delta math?
Like,
Oh, how do you enter it?
yeah,
Hey guys,
I know how to enter it.
when you check a solution and it's extraneous and there's no solution, have you guys figured out how to do that in delta math yet?
I don't think I've got one yet, where there's no solution.
Some
I did, and it was so weird because like it was just like the two like parentheses thing.
Okay. The reason why it could be helpful to factor is because you might discover that a factor of this is also a factor of this. In this case, it didn't happen. If I could factor out an x, then I would see that x is already a common factor. That would be helpful. It didn't really help here. So I factored out the 2, but since I didn't find anything in common, doing this problem the same way we did it before would not hurt at all, which is, Blaine, you worked ahead, right?
Yeah.
Yeah, and when Blaine worked ahead and solved this with the old method, it still worked fine. But you do want to factor because often you'll find that you have a common factor. And you only have to worry about, in the beginning, factoring your denominators because you don't need a common numerator, you just need a common denominator. So on this side, we're missing both of them, right? I'm going to use this pen. Okay. So we're missing both the 2 and the x minus 3. And on this side, we're missing the x. Okay. So I'm going to multiply the 5 times the 2 to get 10, and then distribute the 10 to the x minus 3. So I'm going to get 10x minus 30. All right, I kind of did 2 things at once there. 5 times 2 is 10. 10 times x is 10x. 10 times 3 is 30. Just 8x here. All right, and then we're going to, of course, eliminate our denominators by multiplying through by that whole denominator. And then I've got this. Okay, now I want you to take a minute to try to solve that linear equation because that is something that we need practice on. Did you guys choose to subtract 8x or 10x? 8x? You get to pick. Okay, so if you subtract the 8x, remember to put the equal 0 there. It also works to subtract the 10x. It's fine either way. So I get 2x equals 30. You guys got 15? Does it work? Is it okay in the denominator? Yeah, I can check it. And if I do 2 times 15 minus 6, that does not equal 0, so I'm good. All right, the next one is interesting because we don't have to factor it. However, our lowest common denominator might be a little bit less than you think it is. Let's look at 2. All right, so in the denominator, we've got 2 times x, and we also have x squared. What would be our lowest common denominator? We do need x squared, and we need the 2. Is that going to be enough for our least common denominator? It says least common multiple. Okay, denominator. Okay. All right, guys, this is enough. What might somebody think we need to multiply by, though? What else do you see that somebody might think we need? The x, right? So it's a little bit confusing that we don't have to put x here, but the reason we don't is because x is a factor of x squared, right? I can multiply 2x by something to get 2x squared. 2x times what would give me 2x squared? X, right? So since I can do that, all I need for my least common denominator is 2x squared. I don't need to multiply by another x. So here, just like you guys told me, I'm going to take, I need space. I'm going to take my 3 over 2x and multiply it times x over x. And then I have 1 over x squared. And what is that denominator missing? The 2, good. So I'm going to multiply it by 2 over 2. And then the last one, it's got everything, right? It's good. All right, so let's put the 2 on the left. Let's put those together into one fraction. So I've got 3x plus 1 times 2 is 2. Three x plus 2 equals x minus 2. Here we go. Multiply both sides by that denominator. And cancel. Okay. Bring everything else down. 3x plus 2 equals x minus 2. We got to get our x's to one side. Do you guys want me to subtract x or subtract 3x? Okay. That was not what I expected you to say, but here we go. All right, what's 1x minus 3x? It's negative 2x, right? And then add the 2 to both sides. So I get 4 equals negative 2x. And then divide. So I'm getting x equals negative 2. Anybody else get x equals negative 2?
I got that as well.
Okay. Is that okay in our denominator? Yeah. It checks out because it would be 2 times negative 2, that's negative 4. It would be negative 2 squared, that's positive 4. And then this one would be 8. They're all good. Okay, so x squared minus 16, it factors to x plus 4 times x minus 4. And so this fraction is missing the x plus 4. This fraction is missing both of them. So I can bring everything down to where I have a little bit more space. Okay. Good morning. Thank you. All right, so this fraction is missing x plus 4, so I'm going to put that. One moment. Let me just finish this line up, okay? This one is missing both the x plus 4 and the x minus 4. Okay, so everybody now has a common denominator of x plus 4 times x minus 4.
Why does the one get both on like top and the bottom?
That's a great question. Raise your hand if you can answer that question. Why does the 1 get both x plus 4, x minus 4 on the top and the bottom? Blaine, you want to say it? I can't hear.
Is it to balance?
To balance. So it has to be on the top and the bottom because in a way it's balanced. It's saying that you're basically multiplying by 1. If you put it on the top and the bottom, something divided by the same thing is the number 1. So you're allowed to multiply by 1. And then are you also asking, like, why does it get both things? Like x plus 4 and x minus 4? So it's missing them both. It has no denominator. So it has to get anything that it's missing in its denominator so that it can have a common denominator. We're about to, but wouldn't it will be different if we cross them out now or later. You mean like I'm not going to cancel this one and this one out because I need the common denominator. But what I am going to do is multiply both sides by x plus 4, x minus 4, and then they'll cancel. But not the top. The top won't cancel. Okay. All right, so first thing I'm going to do is just combine these two if I can somehow. So let me move this over a little bit. 3x plus 4, x minus 4. All right, so when I multiply this out, I get x squared. I get plus 4x and minus 1x, and those are like terms. Plus 4x and minus 1x, and that makes plus 3x. You guys see that I did two things at once there? I got 4x minus 1x, and so I wrote 3x. Negative 1 times 4 is negative 4. Now, this negative 1 is going to multiply by everything in here, but I didn't want to do too many things at once. When I multiply x plus 4 times x minus 4, I should get back to x squared minus 16 because I factored x squared minus 16 to get it. You can check it though. X times x is x squared. I get minus 4x and plus 4x, and those cancel out. That's why I don't have a middle term. And then I have 4 times negative 4 is negative 16. Okay, just a little bit of trickiness in this negative 1 here because it is going to distribute. But let's try to get rid of our denominators now. So let's multiply both sides by x plus 4, x minus 4 to get rid of our denominators. So, Izzy, take a look. This is what's going to cancel. This one and this one, but I still have this up here.
Okay, got it.
And then this and this. All right, careful here. The negative 1 is going to distribute, so I'm going to get negative 1x squared plus 16. All right, let's continue combining like terms. How many x squareds do we have? I have 1x squared and negative 1x squared. What does that make? 0, right. I have 0x squared, so I can just cancel those out. 1x squared minus x squared, it's gone. I get 3 equals 3x. Negative 4 plus 16 is plus 12. minus 12. Negative 9 equals 3x, and then divide by 3. So x equals negative 3. Okay, go ahead and check that. See if it makes any denominator 0. All right, 9 minus 16, not 0. Negative 3 minus 4, also not 0. So it checks out. Okay, so we factored x squared minus 1 to be x minus 1 times x plus 1. And now we need to make sure every fraction has the same denominator. So I'm going to multiply this one times x minus 1 over x minus 1. And this one, x plus 1 over x plus 1. And this one's fine. Okay, here we go. All right. So I want to distribute and combine into one fraction. So here's my x plus 1, x minus 1. 2x minus 2 plus x squared plus x. All right, and then I saw some of you guys think you know that the denominators will cancel and you just cancel them. And that doesn't bother me. But the step that we can do to show that they cancel is just to multiply both sides by that denominator. All right, and then when you combine like terms, it's nice practice to put it in standard form so you can see what you're dealing with. Okay. When I end up with a quadratic equation, there are a few different ways to solve, but we've been really focusing on one method for solving a quadratic equation in this unit. What method is that? Factoring, yeah. So we're looking for something we can factor. In order to solve by factoring, one side has to equal what number? 0. Good. So to make one side 0, I'm just going to subtract the 2. And then we're looking for numbers that multiply to negative 4 and add to 3. Juan, did you find them? Plus 4 and minus 1. Good. All right, so now if I have the product of two terms and the answer is 0, one of those has to be 0. That's the only way the product can be 0, is if either this is 0 or this is 0. It's called the zero product property. So I'm going to set each one equal to 0 to find my possible solutions. All right, so I have two solutions. What do I need to do next? Check them, right? So check them to see if they make the denominator 0. You're going to check them separately. So to check negative 4, I'm going back to the original problem. Negative 4 plus 1, that's good. Negative 4 minus 1, that's good. Negative 4 squared minus 1, that's good. So it checks. Okay, 1 plus 1, that's good. 1 minus 1, what happened?
0.
Okay, so that means that this is extraneous, but we do have a solution. It's just the other one, okay? Yes. So one of our answers didn't work, the other one did work, and we have just one solution.